Yeah, I've tried to organize with my phone, but my phone spends maybe 80% of its life, 80 to 90% of its life on vibrate and silent. Because I don't want it like going off. Unless I know something's going to happen, then it's on loud. So, like we were saying, we already talked about sine, cosine, tangent. Here are those ratios. One of the question was, is this always going to be the adjacent side? Well, that's not necessarily true. We're saying that because right now we're looking at this triangle from this viewpoint of theta. If for some reason, let's say we were up here and let's call this bad boy alpha. If I was up there from the viewpoint of alpha, then is the opposite still the opposite? No, it would become the adjacent. And then the opposite would be, sorry, the adjacent would be the opposite. So they would flip roles. But technically when we're doing these trig problems, the angle that we're always looking from, about 95%, 90-95% of the time, is going to be from this viewpoint, from the origin angle. That make sense? So, again, here's a quick layout. Adjacent, opposite, X, Y, R. We should be okay with those. As long as you know what the definitions are. Opposite, adjacent, you should be fine, okay? So, let's jump into this. You guys ready? Here's our first problem. So we have this image, and what they did was they graphed a point, and it's right here. Let me use some blue. Let me use some blue. So here is the point that they graphed. The coordinate to this point is right there. 8, -6. Oh, excuse me, chair. 8, -6. Now again, what do we do with these things? We always come back up, and we make our right triangle, correct? That gives me a lot of information already. Because the coordinate is 8, -6, I know that these are always in the order of x, y, correct? So that means that the length of x is 8, the length of y is -6. And what I need is simply the hypotenuse. Oh, wait a minute, I remember doing this in geometry. I can take Pythagorean's theorem, which reads a squared plus b squared is c squared, right? So if I take 8 squared plus -6 squared, that should give me c squared. Which means 81 plus 64 plus 36 is equal to c squared. That would give me 100 equals c squared. And then square root of both sides, I find that c is equal to 10. So now I have my hypotenuse as well, and that is 10. Right? Now, that's not even the question, though. It's Pythagorean's theorem. We did that in geometry. We got to level up, don't we? The question here is, what are the values of the 6 trig functions? What are the values of the 6 trig functions?
All of them?
Yeah. So, now you say all of them like it's a bad thing. Well, we only really need to do how many of them? 3. Let me tell you why. Can I get rid of this, or are you guys still writing that down? All right, I'll wait for a second. Because once it's gone, it's a lot of clicks to get back to it. .3. Is
this our last lesson?
No, this is the last lesson.
Mr. Munoz.
More than 1, less than 10.
Okay. Really? Oh, wait a minute. That means they're going to be lengthy. Yeah.
You're going to have like parts different.
Part A through M for more.
Like stats. Sorry. Can I get rid of this now? We're good? All right, cool. So, let's do this. I'm going to start, let me use another color here. I'll just use black, cool? All right, sine. Here's my angle, correct? So let's find sine theta. You guys ready? Sine is opposite over the hypotenuse. So negative 6 over 10. Negative 6 over 10 will simplify to negative 3 over 5, correct? And since we're already here, what's the reciprocal of sine? Cosecant. Okay? And it's the reciprocal, so all I have to do is write the reciprocal of sine. Boom.
Does it ask you what you call?
Yeah, it wants all 6 of them.
6 and what?
6 of the trig functions. That means sine, cosine, tangent, secant, cosecant, cotangent. So there's 2 of them. We're a third of the way there. The next one will be cosine. Cosine. Cosine from here is adjacent over hypotenuse. So that's going to be negative 8 over 10. Sorry, not negative 8. Positive 8 over 10. Which simplifies to 4/5.
Wait, why is that not a negative?
Because I went to the positive numbers. X is positive in this direction, right?
Wait, why is it 10 negative?
Because 10 is a distance, it's a hypotenuse. 10 is a distance. Later on, when we start talking vectors, or you do that in science, you'll see that distances are always positives. And the hypotenuse is kind of technically a vector. It's a direction that you're headed in. Yay, mini lessons. Let's continue. I know that the reciprocal of cosine is the secant, which means that the value of secant is going to be 5 over 4. We're 66% done. Or I should say 66.6. 66. All right, let's do tangent. Tangent is opposite over adjacent. So that is negative 6 over 8, which simplifies to negative 3/4. Which means that the cotangent is the reciprocal of that, making it negative 4/3. And we're done.
That's all we have to do.
Yeah.
You sure?
For this problem, yes. Quite sure. Quite. What?
This has been the easiest part out of all of this.
They all are.
No, they're not. No.
Once you wrap your head around what you're doing, once you know the rules, what do I have to say? Once you know the rules, you can play the game.
Doesn't mean you play it well.
Hey, we can all be Kobe, okay? Kobe. All right, can I change this now? No? Oh, hello. All right, cool. Let's have you guys try it. Find me all 6 trig ratios for this coordinate.
What did you just say?
Find all 6 trig ratios for that. Now, for those of you that don't remember how to graph a point, negative 5, 1, 2, 3, 4, 5 is here, and 12 is up here somewhere. So the coordinate should be here, and there's my...
Why didn't you just do that? Wait, what?
What?
Without graphing?
I did. I graphed the coordinate.
I said, can you do it without graphing?
Yeah, you actually could. But that means that you know exactly what's happening.
Graphing. I don't know anything that's happening.
Yeah, because you just asked me that question, which means that you knew that there was a possibility that you could. absolutely yes. Sorry, not sorry.
Wait, I don't think I did that.
Border on an island. China. Thank you.
Do you like shrimp?
I love shrimp.
So now I'm gonna go home and make.
Hold on. How do you make shrimp?
Like, I said, guess what I'm gonna go home and make?
Shrimp?
I said I was gonna make shrimp.
Shrimp cocktail.
No.
Battered shrimp.
No. Shrimp pasta.
Oh. Lemon shrimp.
That's good. Just like a.
Here's what the wife makes with that. She takes the zest from a lemon, put it in some olive oil, and let it just soak like overnight.
Like the shrimp soak in it? Or
No,
just
in the oil. And that's what you'll fry the noodles in, or the spaghettis, depending on what you're using. And then you throw lemon juice in there, just so lemony. Oh, delicioso.
That sounds good.
It's bomb.
I had it yesterday with avocado and some cucumber, and then I put the I don't even know what it's called. Start with a Q.
Cucumber? Quinoa.
Yeah, that. I put that. That was alright.
Quinoa.
Different textures.
Quinoa. Yeah, quinoa's alright. My wife loves it. Because I always hear the kids go, Mom, I don't like it. Mom, I don't like it. So I was like, so, this is going to be a -5, 12, right? What'd you guys get for the hypotenuse? 13. Solid 13?
Yeah.
Swing batter. 5, 12, 13. Okay. So, let's start with, here's my theta. Let's start with sine. Sine is opposite over hypotenuse, which means 12 over 13. Since we're already here, we'll do cosecant at 13 over 12. Then we'll do cosine. Cosine is adjacent over hypotenuse, -5 over 13. And since we're here, we'll do the secant, which is going to be -13 over 5. Finally, we'll do tangent, which is opposite over the adjacent. And since we're there, we'll do the cotangent, -12 over 5. And there's all 6. I didn't switch them?
No.
JK smiley face, lol. There we go. -5 over 12. I started flipping and then I didn't.
Huh.
But there you go. Not so bad, y'all. You can do it.
What's next?
It makes sense?
Yeah, but what's next?
Oh, wait, there's more.
No.
Yes. Let's continue. Wait. Whoa. I'm trying to whisper something in my ear.
Snuff fly.
How to catch that fly? I'm going to choke it out. Punch him in his eye.
Give Malik electric.
Electric. Well, those are, I have one too. I should bring it. Oh, sorry. That was electrifying. All right, can we switch it now? All right, cool. So check this out. Can you guys see this picture? So they have this. This is the glass pyramid at the. They got this glass pyramid at the Louvre, and what they want us to find is how tall it is. Now you can barely see some of these numbers. I'll try to make them a little bit. I know. That's why I said you could probably barely see them. But here's what we can. Let's see. I'll use some red maybe. Oops, wrong side. So here is the base. Here is that hypotenuse. Use green. Let's see here. Clear that. Let's get something bright, huh?
Do it yellow.
Let's see here.
The yellow will be brighter.
Oh, here. This will be bright right here. Oh, let's use this line. Never mind. This red? That's good, huh? Pops? Yeah? Alright, let's undo that then. Let's try. That was bad. Let's try this line again. Maybe green?
Do white.
Oh, yeah, touche. Let's make this a little bit thicker though. Let's go like this. Oh yes, look at that. Booyah. So there's the base of the triangle, and here's the height of it. You see it? And then of course the other piece would make the hypotenuse there. So here's what they're telling us. They're telling us that the entire base of this triangular pyramid is 35, which means that the base of this triangle should be half of that. How much is that? 17.5? Yeah. So we've got 17.5 here. Sorry about not being able to see the color. I do know that this angle here is 49.7 degrees. And what I'm after is the height. So put yourself here in this position. I have the adjacent. Which one do I want? I want the opposite. I have the adjacent. I want the opposite. Which trig ratio uses the adjacent and the opposite? Tangent does. So let's use tangent. We are going to go with tangent 49.7 degrees. The ratio of that would be x over 17.5, right? Opposite over adjacent? Cool. Now, excuse me, Mr. Triangle. Here's what we have to solve. X is being divided by 17.5. Yes? What's the opposite of divided by 17.5? It's to multiply by 17.5. I'll do it to both sides. So this is 1, which means x will be equal to this product. All I've got to do is go over to my handy dandy calculator and take 17.5 and multiply it by tangent 49. Was it 49? Yeah, 49.7. Thanks. 49.7. Close that. And there we go. So approximately, how tall is the pyramid at the Louvre?
21.
It's approximately 21. Now, of course, Excel would be a little bit more specific in what it wants, right? You might say round 2 decimals or round to the nearest whole number. But I think we get the point, yeah? How was that?
I think how the calculator makes you close it.
It doesn't make you. You don't have to do it. Here, watch.
Why is it? Oh.
Oh, not cosine.
I
Tangent.
figured out my problem. I was in ratio.
Yeah. Be careful with that. Whoa. All right, cool.
So, how did you know to use tangent?
Because, let's go back to the picture. That's a lot of clicks back. Here we go. See how I have, whoa. So, I have this angle, correct? So this is the viewpoint I'm sitting at. And I have the adjacent side, which is 17.5, and I want the opposite, because that's the height. So I have to think to myself, which trig ratio uses the adjacent and the opposite?
Did you not find the
Find the length of what? She just had a question now, but I was answering it. We're done with it. What's your question, dear?
No,
Don't be confused.
I'm just confused.
With what? How did we get that base?
Yeah, like, why do we need tangent? I thought we were just going to be finding egg. Wait, I'm just, I don't know.
Okay, so let me do this real quick. So the triangle looks something like this. We know that this is 49.7 degrees, and we know that this is the height. We're after that. So x is technically the height. Are you okay with this triangle? This really is a right triangle, so that means we can use trigonometry. Now, we found the base because it was half the distance of the whole thing, right? Which ended up being 17.5, not 17.5 degrees, what am I talking about? 17.5 meters, I believe. Now, what would have been your original plan of attack? Well, how would you have figured out what x is by itself, the way it is right now? You're probably thinking Pythagorean theorem.
But that wouldn't work because you're missing the
I'm missing two sides.
So don't you have to do something like this?
Wouldn't you use the one side and then find?
No, you don't.
So see how trig comes in and helps us out? If I'm missing two sides, but I do know this angle, well then I just ask myself, I have the adjacent side, I have the adjacent, okay? I have this angle, so I have to work from here. So I have the adjacent side, and I want the opposite. So which trig ratio uses opposite and adjacent? The tangent. So does the cotangent. The tangent and the cotangent use those, right? But I don't really want to use the cotangent because it's not on my calculator. Okay? So that's why we did this. Now let me show you my setup. Okay? The tangent of 49.7 is just some ratio. It's the ratio of opposite over adjacent. So I just plugged them in. What is the opposite side here? Oh, I don't know it. We're calling it x. So this opposite becomes x. And this adjacent becomes at 17.5. And then at this point it's just algebra.
Yeah, okay.
What confuses a lot of people, and confused me, to be honest, was that I always thought this is supposed to be something.
Yes.
And it's not. It's not. Tan 49.7, all of it together, is just some number. Here, check it out. Tan 47. Boom. If I did tan by itself, it's going to say, what are you talking about, bro?
Wait, can you go back
To what?
to the left?
To here?
Yeah. You've got 1047.
Yeah, tan 47. Tan 47 is just some number.
Tan something?
No. Because remember, sine, cosine, tangent are just, they're just a call for a ratio. Here, let's do this real quick. Do you guys remember those two special triangles? Let's do the 30, 60, 90, okay? 30, and I know that opposite. 30 is 1, this is 2, this is radical 3. Okay? Now remember how I keep saying sine is opposite over adjacent. Cosine is, that was wrong. Sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, right? Those three things, or six things, sine, cosine, tangent, are all they're asking for is that ratio, is a fraction of those things. If I was to ask you for the sine of 30 right now, the sine of 30, what would you tell me it is? Well, sine is opposite over hypotenuse, correct? And what is that? It's 1 over 2, aka 0.5. So I'm telling you that all of this is simply equal to just that. It's just a ratio. Does my calculator know that? Sine 30. Yes, it does. The only thing the calculator does is spit out all the values for sines that you want. Sine is just a call for something. Kind of if I told you, hey, you know what, do this. Well, don't do that because I didn't write it all. If I asked you to do something like this, if I said, hey, you know what, do this problem for me. Exactly, it's incomplete, isn't it? Because division is just a call for something. Well, so is sine, cosine, tangent. It's a call for something. And what is it a call for? Some fraction that I don't know what it is until you tell me what angle you want. Yeah? Let's continue. Okay. Finding trig ratios. They're telling me that there's this one triangle, and it's a right triangle. So I'm going to draw me a right triangle, just like this. And they're saying that C is the right angle. That's very important. Now this is triangle ABC, so I'm just going to go A, B, C. Cool with you guys? Hey, get over here. You guys okay with that? I just read the first part. In triangle ABC, angle C is the right angle. And then they gave me something very important. What did they tell me? That the sine of A is 5 over 13. What does that mean? Yeah, exactly. So if I'm right here in A, because that's angle A, right? The opposite side would be 5 units, and the hypotenuse would be 13 units. Does that make sense? So here's what their question. Hey, you know what? They want us to answer what is the cosine of A, what is the cotangent of A, and what is the sine of B. So these are the 3 questions they want me to answer. All right. Well, in order for me to do cosine, what do I need? I need the adjacent, don't I? So to find this missing side, I could just do Pythagoras theorem. I'm going to switch over to a new slide real quick. Is that cool with you guys? To do that Pythagoras theorem? Let's call this little b. Cool? So we've got 5 squared plus b squared is equal to 13 squared. 25 plus b squared is equal to 169. Take away 25 to both sides. That means that b squared is equal to 144, which means if I take the square root of both, b is just 12. So now, I know that b is 12. And now can I do my cosine? Sorry, go back to here. So,
Okay, I'm still just like really mad over this. So when you're trying to figure out like which one is considered the opposite, I always because I put the 5. Like, the
okay,
ones,
so let's do this one more time. I'm going to open up a new slide. You understand the word opposite, right?
yes.
Like,
I thought it would be like opposite of the hypotenuse.
we all understand the word opposite. What did I say about the hypotenuse?
It's a distance.
The hypotenuse is always the hypotenuse. It can never be anything else other than the hypotenuse. Okay? Once you figure these 3 things out, and once they click for you, you'll be okay. Hypotenuse can't be anything other than the hypotenuse. It's always along the side. Okay? That means that you have to decide between 2 things. which side is opposite, and which side is adjacent. Adjacent, it just means next to. If you're adjacent to me, you're just next to me. Okay? And if you're opposite to me, you're on the other side, like Lashana. Hey, Miss Opposite. That make sense? So, here's the triangle. We'll call this A, we'll call this B, and we'll call this C. Okay? And I'm just going to make up some sides. Cool? It's actually a legit triangle. This triangle is called the 3, 4, 5. 3, 4, 5. Don't believe me? Do Pythagorean theorem. It'll work. What's it called? 3, 4, 5. Okay? Now, I have to decide where I'm going to stand. Okay? Because if you think about this, if I'm standing right here, she's next to me. Lashana is opposite to me. Right? So, but if I go over here, is Lashana still opposite to me? No. Who's opposite to me now? Amaya. And Lashana would be next to me, right? So it really depends on where I'm looking from. So that's the same thing. Over here, you really only get 2 viewpoints. You can be looking from here, or you could be up there looking down. And that is very important to tell you the difference between the two. So let's stay up there, okay? Let's stay up at B. What is this side called? This long side? Can it be the next? Can it be the adjacent? Why not? It's just the hypotenuse, always. So you are the hypotenuse. That leaves me with this side, and it leaves me with this side. Correct? If I'm standing up there, which side is opposite to me? And which one is adjacent to me? That's it. There's nothing else. Nothing else to do. But what if I'm standing here? Is 3 still adjacent to me, or is it opposite to me? See how now it's next to me? What about the 5 though? It's hypotenuse. And it always works that way. So what I tell people is, imagine yourself, you're a tiny little person, and you stand right there. What's opposite, what's adjacent? And there's only 2 to choose from. And opposite is, you're on the other side, right? So when we get back to here, and we're looking for cosine, I'm standing up here. That's why I put theta in there. I'm standing up there in the viewpoint of A. So which side is adjacent to me? The 12. So I write 12. And I have to put that over the hypotenuse, which is 13.
And then we know we're looking from A because it says
Cotangent A.
Okay, yeah.
That's where I have to be. Now cotangent, tangent is opposite over adjacent, right? Which means cotangent is adjacent over opposite. So I want to write, what is it?
13.
Okay, cotangent, I'm going to go back and take a look. It's supposed to be adjacent over opposite.
12 over 5.
Absolutely. And I'm done. Now, what about sine B? Opposite over hypotenuse.
5 over 13.
So 5 over 13 is not correct.
12 over 13.
Hold on. Tell me why.
Wait. You're looking for
It's a different viewpoint now. So I have to change where I'm looking from. Now I'm looking from here. Because they told me look from B. So now when I go over here, oh, sine of that, that's going to be 12 over 13. Catch that?
And then is A always going to be like the top part?
It just depends how you draw it.
So is it safe to say that we could label B as always resting on the opposite side of the 90 degrees?
Say that one more time.
Is it safe to say that B is always resting next to the 90 degrees on the same side?
No, because I could swap those. I could swap those. I could have made this A and this B. But then that would change all these values, right? But I would still get the same thing. I would still get the same thing. Check it out. Cosine A is 12 over 13. Sine B is 12 over 13. So like I said, it really depends on how you draw it. As long as you know which one is the right angle, you should be okay. Here, check this out. Here's another triangle for us. Okay? So this triangle, we're calling it triangle DEF, where D is the right angle. So D goes here. So E, F, D. And they're telling me that the tangent of E is 3/4. What does that mean? This is tangent, not cotangent. Yeah, so tangent is opposite of adjacent. So tell me what I put here. 4. What do I put here? What goes there? I gave you the name of the special triangle. It's a 3, 4, 5. And you can do Pythagoreans if you don't know it yet. But then now we just do them all over again. Right? Let's find, they want us to find the sine of E. So where am I going to draw my theta? Up at the top. Okay, sine is opposite over hypotenuse. 3/5, and I'm done. They want secant F. They want secant F. What's my viewpoint? F. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, which means I want to do hypotenuse over adjacent. So what is it? 5/3, and we're done.
Can those numbers be negative?
Not if it's in this scenario. It could be negative if they gave us some situations where they gave us like coordinates like this. See how here they were? This one was negative because they went back.
Could the hypotenuse ever be negative?
No, because the hypotenuse is a distance. Okay, hypotenuse is a distance you're traveling, a direction. Okay, and we know that distance is always absolute. You guys want to do this word problem? Go back to him. I think we're in a good spot to stop right now.
Yes.
Okay? I don't want to throw in the word problem and then just have you guys break down. If you guys get to the word problems on the homework and you have questions, we can go over those on Monday. Okay? Tomorrow's your writing final. So let me stop this.